Okay, over the next two videos, we're going to talk about simultaneous equations. There are two main types of simultaneous equations on the Leaving Cert. The one we're going to talk about in this video are simultaneous equations with three variables. You'll be given three equations and you'll have three unknowns. For the most part, they're basically the same as what we did at Junior Cert level. At Junior Cert level, you had two equations and two unknowns, and you tended to add the two lines together so that one of the letters would cancel, and you were able to, if you had two equations, you were able to find two unknowns. We're more or less going to follow the exact same logic to solve a question like this. I've written out three equations here in x, y, and z. If I have three equations and three unknowns, it's possible for me to find all three variables. These are really messy questions, and students tend to make little sign errors or tiny little mistakes. In order to try and avoid that, you need to be really structured. And part of that structure involves labeling your three equations. I would always call my equations something like A, B, and C, or 1, 2, and 3. In this case, I'm going to call the first equation, equation A. I'm going to call the second equation, equation B. And I'm going to call the third equation, equation C. I need to eliminate either the x's, the y's, or the z's. It doesn't matter which one I eliminate, I'll end up with the same answer either way. If I'm looking at this one, it's clear to me that the easiest letter to eliminate is the y's, because there's a 1y here and a minus 1y, so those can already cancel each other out, and there's a 4y here. It'll be relatively easy to cancel out my y's in this case. So what I need to do is I need to take two of these equations and try and cancel out my y's. The easiest ones to take here are equation B and equation C. Think back to what you would have done at Junior Cert. If I just add equation B and equation C together, my y's will cancel and I'll be left with an equation that only have x's and z's in it. So I'm going to write out, I'm going to structure this nicely. I'm going to label B and C to indicate that I'm going to write out equation B and equation C. Equation B is 2x plus y minus 3z is equal to 16. While equation C is that 4x minus y plus 4z is equal to 0. At Junior Cert level, what we would do is we would manipulate it or multiply one of the equations by something so that one of the letters will cancel. However, the way that this has already been structured, if I add these together, the y's will already cancel. Plus 1y minus 1y is 0. So that's my goal. So all I need to do now is just add the two lines together. 2x plus 4x will give me 6x. 4z minus 3z will give me 1z. And 16 plus 0 will simply give me 16. So now I have an equation with two unknowns, just an x and a z in it. And what I'm going to do is I'm going to refer to this as equation D. And I'm going to come back to equation D in a moment. But for the moment, it's not really useful to me. I'm going to now look back at the three original equations. I need to take two of the equations and I need to eliminate the y's. I've eliminated the y's using B and C. So now I can either take A and B or I can take A and C. It doesn't matter. What I'm going to do is I'm going to take equation A and equation C. In A, there's a 4y. So that means that in C, I want to have a minus 4y. So first of all, I'm going to rewrite equation A. Equation A is 3x plus 4y minus 2z is equal to 29. I can group that with B or with C. It really makes no difference. In this case, I'm going to group it with C. I need to figure out what do I need to multiply this term by so that it will be a minus 4y. Or in other words, so that it will cancel with this one. This is a minus 1y, so if I multiply it by 4, the y's are going to cancel. So this time I'm going to rewrite 4 times c. I'm taking equation A exactly as it is, but then c multiplied by 4. 4 times 4x gives me 16x, minus y times 4 gives me minus 4y. While 4z multiplied by 4 gives me 16z, and I know that that is equal to 0. The whole point of multiplying equation C by 4 was that so the y's would cancel. I have 4 plus 4y minus 4y, so they're going to cancel each other out. I'll now just add my x's, z's and numbers together. 3x plus 16x gives me 19x. 16z minus 2z will give me 14z. And 0 plus 29 will give me 29. Now I have a second equation that only has x's and z's in it. So I'm going to call this one equation E. I want you to now look at the two equations that I've highlighted, that I've generated and highlighted. I now have two equations with two unknowns. Equation D and equation E only have x's and z's in them. So I'm actually now at the point where the exact same as what I used to do at junior cert. At junior cert, if we have two equations and two unknowns, we were able to find x and z. So I'm going to ignore these three for the moment, and I'm going to simply solve the two simultaneous equations D and E. Find the value of x and the value of z. Once I have a value for x and a value for z, I'm going to sub back into one of these original equations, and I'm going to find a value for y. So I'm going to wipe this off now and just take these two equations and work from there. So I've rewritten equation D and equation E. And in this case, I noticed it's probably easiest to try and eliminate the z's, because if I have a 1z, I can manipulate it and turn it into any number I want. In equation E, I had a 14z, which means that in equation D, I want to have a minus 14z. If I currently have a 1z, in order to turn that into a minus 14z, I needed to multiply equation D by minus 14. In which case I got minus 84x minus 14z minus 224. And if I now add these two lines together, my z's will cancel. Minus 84x plus 19 is minus 65x. Minus 224 plus 29 is minus 195. Divide both sides by minus 65 and you get x equals 3. Now that I have a value for x, I can sub into either equation D or equation E in order to find a corresponding value for z. So let's sub into equation D. I could say that equation D is 6 times 3 plus z equals 16. I've just rewritten it, except instead of an x, I've subbed in a 3. 6 times 3 is 18 plus z equals 16. If I subtract 18 from both sides, I get z equals minus 2. So I now have a value for x and a value for z. Once I have a value for x and a value for z, I'm going to look back to either equation A, B, or C, and I'm going to find the corresponding value for y. Okay, so equation A was 3x plus 4y minus 2z equals 29. But I've now deduced that x is equal to 3 and z is equal to minus 2. So I've simply subbed in x equals 3 and z equals minus 2. It's a basic enough question. I work through it and I end up with y equals 4. So I now have a value for x, y, and z, so that would get me full marks. So to be honest, I'm not really showing you anything new here. And as far as I'm concerned, this is it's just like a logical extrapolation of what you had to do at junior cert level. We're not really doing anything new at all. I feel that students who structure these questions well tend to get them right. Even if you fully understand what I'm after doing there, it just, when I give these in exams, the stuff that I get back tends to be so messy. I think it's just important you structure it well. Label it as A, B, and C. Come up with two more equations. Do a simultaneous equation in two variables. And just keep it nice and clear for yourself as well as for your examiner. So I'm only going to do one example here, but I'm going to give you a number of questions that I want you to try yourself. Okay, in order to practice that material, I've given you 3 questions here. Each of these have 3 equations with 3 unknowns, x, y, and z. So you should be able to carry out a simultaneous equation to solve each of these. The first one is relatively standard, while in the second one you'll notice that the second equation only has 2 variables in it. Nonetheless, we still have 3 equations with 3 unknowns in them, so it's possible to find the value of x, y, and z. It's actually easier if there's no value, if there's an equation with only 2 variables in it, but I want to see how you deal with that one. The third one is a number of things we have are fractions. So once again, I'm not going to give you any hints on that. I want you to see how you deal with that one yourself. So I want you to pause the video now, try these 3 questions, and then compare them to my solutions. Okay, so in the first question, I give you 3 equations. The first thing I would always suggest that you should do is label them as A, B, and C. Now you have to look at this and decide which one of your variables are you going to eliminate. It really doesn't matter whether you eliminate your x's, your y's, or your z's. In this case, I've decided to eliminate my z's, because in the first equation I have a plus 1z, and in the second one I have a minus 1z. So straight away, if I take equation A and equation B, the z's will cancel. And then since these are both 1z's, I can easily turn them into a 3z if needs be. So probably the easiest letter to eliminate there were your z's. The first thing I did was exactly what I described there. I took the first equation and the second equation. I didn't actually need to change either of them because I have a plus z and a minus z. So if I add these two equations together, plus z minus z is 0. If I add my x's, I get 5x, and if I add my y's, I get 3y. And if I add my numbers, I get 7. So that gives me a fourth equation, and this is the first equation in which there are only two variables. The only variables here are x and y. So I label that equation as D, and I'm leaving it B for the moment. Once you've got one equation with only x's and y's in it, you need to come up with another equation with only x's and y's in it. So since I've taken A and B already, I now need to take A and C, or else B and C. It doesn't matter which one. There's 3 different combinations I could use. I only need to use 2 of them. What I've decided to do is to take the second equation and the third equation. Since the third equation has a plus 3z, I know that I need a minus 3z in the other equation. And in order to get a minus 3z, I already have a minus 1, so I need to multiply by 3. So what I've done is I've written out 3 times b and c. 3 times b means you're rewriting the second equation except you're multiplying by 3. And I got 9x minus 3y minus 3z equals 6. And then I just rewrote my third equation and added them together. 9x and 5x is 14x, minus 3y minus 6y is minus 9y, my z's will cancel, and 6 minus 25 over 2 gives me minus 13 over 2. So now I have 2 equations with 2 unknowns. And now I'm right back to just junior cert simultaneous equations. It's going to be relatively easy here for us to find the value of x and then the value of y. So I've taken my equation D and equation E. And I noticed it's probably easiest in order to eliminate the y's. E has a minus 9y in it, so I want to multiply D by 3, because 3y multiplied by 3 will give me plus 9y. So I've rewritten 3 times D and E together. When I do that, I can now add the 2 lines together. 15x plus 14x gives me 29x, the y's cancel each other out, and if I add the constants together, I get 29 over 2. In order to get x on its own, I divide both sides by 29 and I get x equals a half. And now that I have a value for x, I could sub into either D or E to find the corresponding value for y. I decided to sub into D, which was 5x plus 3y equals 7. Instead of x, I can sub in a half, and I end up with y must be equal to 3 over 2. And now that I have x and I have y, I can sub back into one of my original equations to find my third variable. So what I've decided to do is to take equation A, which was 2x plus 4y plus z equals 5. Instead of x, I can sub in a half, and instead of y, I can sub in 3 over 2. And I use that to work out that z, the third variable, must be equal to minus 2. Okay, in the second question, once again we were given 3 equations and there's 3 unknowns. However, in the second equation, which I've now labelled as B, there's no y value, which means that I already have an equation with only 2 unknowns. This is useful to me because it means if I can just get one more equation with only x's and z's in it, then I can carry out a simultaneous equation with 2 equations and 2 unknowns. So what I decided to do was to take equation A and equation C and try and eliminate the y's, because this one already doesn't have a y, so it's going to make the question a bit shorter for me. I realised that here I've got a minus 7y and here I've got a plus 3y. The smallest number they're both going to divide into is 21. So if I multiply A by 3, this will become a minus 21y, while if I multiply C by 7, this will become a plus 21y. So if 3 times A is 42x minus 21y minus 3z equals minus 18. While 7 times C is 28x plus 21y minus 35z equals 128. And in this case, the x's add up to 70x, the z's add up to minus 38z, and the numbers add up to 108. So now I want you to draw your attention to equation B and equation D. The equation given in the original question only has x's and z's in it. And the one equation that I've formed here only has x's and z's in it. which means that I can carry out a simultaneous equation using b and d. I don't need to get another equation at all. I'll be able to find x and z using just b and d, and then I'll sub back into either a or c, and I'll find the value for y. I want you to be aware that in a question like this, you don't have to do it the way I did it. You could have decided to eliminate your z's or eliminate your x's and it would still work. It's just far shorter and easier if you hone in on the fact that there's no y in the second equation. So now I have equation b and equation d, two equations with two unknowns. However, the numbers were quite awkward here. And in any simultaneous equation, if the numbers are awkward, there's an easy way of solving it. In this case, I honed in on the fact that at least the z's have different signs, so I won't have to change any signs here. If I can't think of a number that they'll both divide into, just multiply them by each other. If I multiply 38 by 4 and I multiply 4 by 38, I'm going to get the same number. So I simply decided to multiply b by 38 and multiply d by 4. Essentially so that I've got 4 times 38, and that'll be the coefficient of z on the top, and I've 38 times 4, that'll be the coefficient of z on the bottom. So that's a handy way. Like, to get rid of my x's, I could have simply multiplied b by 70 and d by 6. 70 by 6 and 6 by 70 are the same thing. But I decided to eliminate my z's, and when I multiplied the b by 38, I got 228x plus 152z equals 76. If I multiply d by 4, I got 280x minus 152z equals 432. And now I'm happy out because the z's are going to cancel. My x's add up to 508, and my constants at the end add up to 508. If I divide both sides by 508, x works out as 1. And once I had a value for x, I'd sub into either b or d. I decided to sub into b, and I found that the value of z must be minus 1. Now that I have a value for x and a value for z, I'm going to sub back into a or c to find a value for y. So again, it doesn't really matter if I use a or c. I've decided to use a. I know that equation a is 14x minus 7y minus z equals minus 6. I've worked out that x is 1 and that z is minus 1, so if I sub into the equation, I work out that y is equal to 3. So once again, these are easy enough questions, but you just need to be meticulous about them. I think it's very easy to make a silly sign error that messes up the whole thing. So let's try the third question now. So I've taken equation a, b and c here, and I've decided to eliminate my x's. The first thing I noticed was that in the first equation there's a 3x, so in the second equation I want to have a minus 3x. Since there's a 1 there at the moment, I decided to multiply the second equation by minus 3. And I get minus 3x plus 12y minus 6z equals 21. If I now add equation a and minus 3 times equation b, my x's cancel. 3x minus 3x is 0, 12y minus 8y is 4y, while 24z minus 6z is 18z. And then I added 18 and 21 and I got 39. I've labelled this as equation D. It's my first equation that only has two variables or two unknowns in it. And now I'm trying to eliminate the x's from b and c. C already has a plus 2x, so I want to convert this to a minus 2x. This time I need to multiply equation b by minus 2. And I get minus 2x plus 8y minus 4z is equal to plus 14. And then c is 2x plus 2y plus 2z equals 13. So if I add these equations together, once again my x's cancel, and 8y and 2y is 10y, 2z minus 4z is minus 2z, and 14 and 13 is 27. So I've labelled this as equation E, and this is my second equation with only two unknowns. So now if I just take equation D and equation E, I should be able to find the value of y and the value of z. So when I have equation D and equation E, I realise that probably the easiest letter to eliminate here are the z's. Since there's an 18z in the D, I want to have minus 18z in equation E. So in order to do that, I need to multiply the minus 2 by 9. So I multiplied the entire equation E by 9, and I got 90y minus 18z equals 243. If I now add D and 9e, the z's cancel. 90y and 4y is 94y, and if I add my numbers together I get 282. So I divided both sides by 94 and I worked out that y is equal to 3. Once I had a value for y, I subbed that back into the original equation D, and I found the corresponding value for z is 3 over 2. And now that I have y and z, I'll go back to one of the original three equations and I'll find a value for x. So I've worked out that y is equal to 3 and z is equal to 3 over 2. I've taken equation C here, which was x plus y plus z is equal to 13 over 2. That was the very original one I had. I subbed in y equals 3 and I subbed in z equals 3 over 2, and I worked out that that must mean that x is equal to 2. So that's the answer to the final question in this video. The material here is quite straightforward, but it does require a bit of practice. You need to practice this consistently while you're studying Leaving Cert higher level maths, because often students get it wrong in an exam just because it's the kind of question that when you're under a little bit more pressure, it's very easy to make a silly mistake. If you're meticulous with them, you should be able to get full marks, but it does require a bit of practice every so often.